when we discuss pulmonary ventilation, it's a little more complicated than you would think. It's one of those things that students sometimes have a bit of difficulty wrapping their mind around when we talk about how things actually work. When we think about breathing in, usually we think we're breathing in through the nose, for example, and that it is maybe some kind of a thing happening in the nose that allows us to inhale quickly, for example. That's actually not true. That's not true. When we want to breathe in, it actually comes from the lungs. So, can anyone tell me when we're looking at the thoracic cavity? The thoracic cavity. What is the muscle at the base of the thoracic cavity that divides it from the abdominal pelvic? Very good. So the diaphragm is actually shown anytime you see the thoracic cavity. You can actually see this domed muscle here. And when the diaphragm, it has a G in there, diaphragm, when the diaphragm contracts, it actually pulls down. This is significant. We're going to be talking in a moment why. So the diaphragm, when it contracts, it pulls down. Come this way. Back here we have pretty much the only model that I found in this lab that has the external intercostal muscles. So there are internal intercostals, but the ones that are important for today's lesson are the external intercostal muscles. External intercostals, and they're shown here. The term intercostal means between the ribs. So you could actually see those muscles here. It's possible that when you were doing muscle anatomy last semester, your professor may have covered the external intercostals. I don't think I did actually, but anyway, here they are. External intercostals. So what happens is, when the diaphragm contracts, it pulls down. When the external intercostal muscles contract, they pull up and out. So if you watch my hands here, the diaphragm pulls down like this, pulls down. The external intercostals take the rib cage and actually pulls it up and out, thus making the thoracic cavity larger. Both of these muscles will usually contract at once. I think a lot of people know about the diaphragm being a prime mover of ventilation or of respiration, but a lot of times the external intercostal muscles are left out of that story. So next, what we're going to do is we're going to talk about Boyle's law. We're going to be doing a little bit of calculus today. Boyle's law. There's a few different ways that Boyle's law is described. Like, for example, you may have learned it as P1V1 equals P2V2. We don't actually do calculations in this class, at least not that type of calculations. I have always found it to be tricky to get those numbers just right and to make the calculation correctly. So we actually do Boyle's law like this. We say PV equals K. Boyle's law, as far as we're discussing it in lab, is PV equals K. So that means, therefore, P equals K over V, or V equals K over P. You see, that's how it kind of comes out. Who cares? Well, the reason we care about this is that there is an inversely proportional relationship between P and V. So P is pressure, and I know some of you are sweating right now. You're just like, oh my God, I didn't know we were going to be doing physics today. I would have skipped. And V equals volume. So P equals pressure and V equals volume. All this to say, the idea is that there's an inversely proportional relationship between the volume of the lungs and the pressure of the lungs. Now, I'm going to write down a bunch of stuff over here. You may not process it all together right away, but you do have to eventually get it. There are some follow-up concepts that are quite important for all of these things. So some of you will get it right away, and some of you it'll be a little bit trickier to, you just need to spend a little more time on it. Don't run away from the lesson. Just keep reiterating it, seeing if you can approach it from different angles. Okay, so let's describe an inhalation. What happens during inhalation, when you actually inhale air into your lungs, is that those two muscles contract. So what are the two muscles again? Diaphragm. And? Very good. Your external intercostal muscles. Both of these muscles are going to contract usually at once. So when the diaphragm contracts, it pulls the lungs down, or it pulls the cavity down. When the external intercostal muscles contract, they pull the lungs, they pull the cavity up and out, and both of these together increase the volume. They increase the volume. So you increase the volume of the thoracic cavity. When you increase the volume of the thoracic cavity, what decreases? Very good. Your pressure is going to go down. When you decrease the pressure in a relatively closed structure, what this creates is a vacuum. And that's how inhalation occurs. You create a vacuum, air rushes into a vacuum, nature abhors a vacuum, therefore you're going to be equalizing these pressures. There's only a very slight difference in pressure between the outside air and the inside of the lungs, and air fills it. Air fills the lungs as a result. And that's actually how inhalation occurs. When you want to exhale air, we actually start all the way back from this point here, because it's helpful to think of this methodically. What is it that you want to do when you exhale air? Well, you want to push air out of the lungs. You're going to be pushing air out of the lungs. And how are you going to do it? Let's go through it step by step. We said there was a vacuum here into which air rushed. What are we going to do in order to allow air to leave instead of come in? What's it? Very good. We're going to increase the pressure. Everybody with me? You're going to allow air to be pushed out of the lungs by increasing the pressure in the lungs. You're going to be equalizing the pressures inside and out. It's a very slight difference in pressure from the inside of the lungs to the outside, but it's enough to push the air out. It's like the opposite of a vacuum. Why do you have an increase in pressure? What's it? Very good. You increased your pressure by decreasing your volume. And then the last thing we have to embrace is how it is that you decrease the volume. So remember, when we wanted to increase the volume, you contracted the diaphragm, pulled the cavity down. You contracted your external intercostals, which pulled your rib cage up and out. So how are we going to oppose that? Very good. The opposite of a muscle contraction is a muscle relaxation. So we decrease the volume of the thoracic cavity, relaxed the diaphragm, and the external intercostals. Since that decreased the volume of the thoracic cavity, it increased the pressure, and air was pushed out of the lungs.